Hello guys, so welcome back to this new session. Today we are going to talk about OSI. So I hope you all are ready, and this is one of the most famous models. If I'll talk about OSI, whenever we start with computer network. This is the first thing that is taught to us, right? But from my point of view, rather than just jumping onto OSI, you must be aware of what is IP, how everything works on internet, what different network devices are there, what is the purpose of having one specific device at a specific position. All these questions needs an answer before you jump onto OSI. That is very critical from my point of view. Yeah, again, it might vary from person to person. From my point of view, one must start with OSI model, right? One must start with the basics first, the fundamentals first, and then they can jump on to to the discussion of OSI. Okay, so if I'll talk about OSI model, it as everyone knows, it stands for Open System Interconnection Model. That's why it is known as OSI model. So it is something that is not in reality. If we talk about OSI model, it is a conceptual model. Okay, so it was obviously proposed or developed by ISO, that is International Organization for Standardization, right? So it was nothing but a conceptual model, and on the basis of this model only different models, the most famous one that is known to us is TCP/IP. So that is built on top of your OSI model, alright. So it serves as a basis of every single thing, we can say that, alright. Now what this OSI model does is it basically provides you some common basis through which coordination can be managed between different standards of development, alright. Basically whenever we talk about interconnection between the systems, alright. So what happens is this model consists of various layers. Okay, so why do we have different layers within the model? The reason being that whatever computing systems are there, they have different functionalities, right? So whether it is manipulation of data, whether it is appending IP address to a particular data frame, or appending MAC address to a particular data frame, every single computing system has a different functionality, or different functionalities are there. Okay, so on the basis of those functionalities, basically the model was divided, or the model was split into different layers, or we can say that there were different layers of abstraction. Okay, so as you can see on your screen, I hope my screen is visible to you, alright. So as we can see on the screen that there were different layers, alright, over here. So the first four starting from the top are known as host layers, whereas the last three are known as media layers, alright. So why they are known as this, we'll talk about them as well, but for the time being these are the layers, alright. So all of these layers have different functionalities, and they are quite different from each other, alright. Obviously when we see any structural model like this, we need to know how do we enter into a particular model. Okay, how can we start reading a particular model? That is one of the most critical things, alright. Moreover, we are going to read this model from top, alright. So we are going to study everything from application layer point of view, and we are going to end this thing at the physical layer, alright. Every layer, again I'll repeat it, every layer is very important when we talk about OSI. It is very critical to know about every single layer, about their functionality, because they are different from each other. Whatever the context is, whatever the functionalities, they are different from each other. Okay, every layer has a purpose of its own, alright. So let's get started with these different layers. So let's get started with the the topmost layer, that is known as application layer. Now what happens within application layer, we are going to start talking about it, alright. Just consider a use case. Whenever you try to work with any application, or whenever you try to work with any web application that is there on your mobile device, or on your laptop, or on your PC. Okay, what happens the moment you press on that specific icon, right? So all the features are loaded into that application. Whatever it is supposed to do, all the purposes would be served. But what happens when you click on that icon? The moment you click on that icon, its application layer gets triggered. Now what happens within the application layer, basically all the protocol suites, for example HTTP, HTTPS, or file transfer protocols, all these are invoked at this layer itself. Alright, so whatever we talk about, whatever protocols we talk, called for, all these protocols are used in your application layer, and the layer is triggered right away the moment you click on the application of a particular or the icon of a particular application, be it web application or it is a mobile application or any other kind of application as well. Alright, so now the beauty of this model is whatever data is generated from one layer, it would be passed on to the next layer, and it is the responsibility of the following layer to take care of that data. Okay, so it does not have any assistance from the topmost layer. The only help that it has is the data that is coming to it. Alright, so the data generated by the above layer would be treated by the current layer, no matter whatever the format is. It is the responsibility of the current layer to take care of that data and to process that data. So now the moment you have clicked on that icon, there are various parts of information that are generated, so that those informations are directly provided to the presentation layer. Alright, so whatever data has been generated would be passed on to your presentation layer. Now what happens in presentation layer, this thing is very important to those people who are very much interested in security. Alright, so presentation layer is revolving around this part. Okay, now what happens when the data is passed on to the presentation layer, basically whatever data has been generated, okay, now you cannot keep that data in plain text only, or you cannot move forward with your data in whatever format it has been provided. Basically what you need to do is, there are various forms of encoding of the data, then data needs to be compressed, then data needs to be encrypted or decrypted depending on the whether it is sender or if it is a receiver. If we are talking about sender's point of view, so in presentation layer encryption would take place, compression would take place, okay, encoding would take place. But the moment we talk about receiver point of view, then decoding takes place, decompression takes place, and decryption takes place. Alright, so whatever operations that are applied to your data on the presentation layer, that data would be passed on to the next layer or the following layer, which is known as session layer. Now within session layer, this thing is quite famous to us. Basically the session layer manages something that is known as communication sessions. Alright, so your session layer basically manages communication sessions, that is whatever exchange of information is happening on the network, or basically it is a continuous exchange of information. Alright, so that exchange of information back and forth between the sender and the receiver would be taken care by the session layer. So it manages all those communication sessions for the that are established for the purpose of data sending or receiving the data. Alright, now the session has been established from the sender's point of view. Now what happens, whatever the data is generated right now, that data would be transferred to the transport layer. Now this is where it gets interesting. Alright, this is where it gets interesting. Now if we talk about transport layer, there are various terminologies that come into picture. Okay, so the first terminology when we talk about let me write over here, transport layer. I hope my handwriting is understood by you guys, because it is quite weird, and yeah, it is just readable. Alright, so you guys have to bear with it. Alright, so now what happens with transport layer is, basically it is responsible for one thing that is known as reliable transmission of data. Alright, so now this is the data, but actually this is not the data. What happens is, whatever data has been compressed or encoded, obviously it is in the form of bits, right? This data is in the form of bits, so there is a sequence of bits, something like this. So it would be a long sequence of bits, right? So what happens over here is that now there are two options. Okay, one option is to send the entire bit stream as it is through the communication channel, but the drawback of sending this whole thing is, if for instance collision takes place. Collision is nothing but when the data from multiple sources is present on the same channel, it results in collision. Okay, and basically it corrupts the data. Okay, so what happens is, let's assume that collision takes place. Now what happens in when that collision occurs? Basically when a collision occurs, okay, you need to retransmit the whole data once again. Alright, so this task is very much hectic. Also it would be a lot of burden onto the on our communication channel itself, because the data size is too huge, right? So it requires a lot of bandwidth as well, channel capacity as well, all those associated factors are there. Okay, so rather than sending the entire data stream, what happens is it can divide data into different parts. Okay, these different parts are known as data segments. Okay, so basically your transport layer is also responsible for dividing your data into different data segments, which is also known as datagrams. Okay, so when we talk about or if someone asks you where data segments or datagrams are created or generated, it is they are created at transport layer, due to the reason that we cannot transmit the whole data all at once. Okay, it is a lot of risk. So what happens is, data is divided into different data segments, so that these data segments can be sent over the communication channel pretty easily. Okay, so one of the tasks of transport layer is segmentation, right? But is it so? No, it is not. It has something else which is also known as, it offers multiplexing of data as well. Okay, it offers multiplexing of data as well. We'll talk about multiplexing, demultiplexing as well, but this topic has already been discussed in digital logic designing as well, so the thing is quite similar. Okay, now what happens when data segments are generated? If you'll see one thing, let's say one stream of data is divided into different data segments known as S1, S2, S3 and S4. This is the order. Okay, now let's assume these data segments are sent over the channel, and at the receiver they are received out of order. Okay, because there can be some data segments which are lost. Okay, and how to know whether data segments are lost? With the help of acknowledgements. If no acknowledgement is received for a particular data segment, it means the data segment is lost. So let's say data segments are received in this order. Alright, now how your receiver would get to know whether this data is in correct order or not? Alright, so that is also a problem, right? So what happens is, when your data is divided into different data segments, when your data is divided into different data segments, so I'll write something like this: data segment, and then data segment and data segment. You can continue the whole process. Okay, so data is divided into different data segments. Now what happens is, the first thing that transport layer does is, from which application that data is generated. Okay, so for that we require port number, so it adds something that is known as source port and destination port. Right, because it is required when within a particular device there are multiple applications, right? So how we would know, or how our device would know, that which particular application has requested for that particular piece of data or that particular piece of information? So if WhatsApp has requested for something, WhatsApp is supposed to receive that data only, not any other application, right? If Flipkart is requesting for some data, that data would be provided to, or that data should be provided to Flipkart only. That is done through the help of port numbers. Okay, so that's why source port number and destination port number is required. But still the question is not answered, that how do we ensure that data is received in correct order? So basically we add something that is known as sequence number. Okay, so with the help of this sequence number, let's say it is 1, let's say the next one is 2, let's say next one is 3. So with the help of sequence number only, these data packets can be arranged once again in a particular order. Okay, now this whole structure of data, in which obviously some part of data is present, right? Source port is present, then destination port is present, as well as sequence number is present. Okay, this whole unit is known as data segment, right? Data segment or datagram. Now whatever data is generated from your transport layer would be passed on to your network layer. So it would be the responsibility of the following layer, that is the network layer, to take care of this data. Now network layer has received some data, right? So network layer has received what? Network layer has received this whole thing. Okay, now what is the responsibility of network layer? Network layer is basically responsible to perform addressing of data packets, to perform routing of data packets, to perform traffic control, or basically controlling traffic, which also includes flow control, or things like that. So all these things are there in network layer. So what happens is that first it performs addressing. Now what kind of addressing it performs? Since it is related to network, so network is related to IP address, which is nothing but logical address. So what it does is it performs logical addressing of data. Okay, now the data that has been received earlier, okay, let's say this is the whole unit, whatever that data segment is received, this is the whole unit. Okay, so I'll just write datagram over here, and to this datagram what network layer does is it adds source IP and destination IP. Basically what it means is we need to tell that this is the source IP address, or this is the source device from which this data has been generated, and this is the destination IP to which this data is supposed to be sent to. All right, so this is these things are appended in the network layer. Now this whole structure is known as something that is known as data packet. Okay, or it is also addressed, sometimes it is also addressed as IP packet, because IP address is appended to it, so that's why it is also known as IP packet. So do not get confused with these terminologies, both means similar things. Okay, now whatever structure has been generated through the network layer, okay, after performing all the tasks, it would be sent to another layer that is known as data link layer. All right, so I'll write DLL over here. Okay, now whatever data, okay, I'll write it as data packet. Now whatever data packet is received over here, okay, now we are left with only one type of address, that is known as physical address, right? Or it is also known as MAC. Correct, MAC is physical address, right? So data link layer does what? Data link layer completes one functionality, that is adding source MAC and destination MAC address. Okay, whenever the data packet reaches to a switch, okay, because directly a data packet is not supposed to go to the router, first it goes to the neighboring switch, or first it goes to the switch that is through which our devices are connected to. Okay, so whenever a data is being sent, that data reaches to switch first. Now that switch uses MAC address to identify whether the particular device is present within the switch's network or not. If it is present, then that data would be sent to that respective device. If that MAC address is not present within the switch network, then the data packet would be sent to the upper device, which is nothing but router. In that regard, router makes use of IP address so that the data can be routed at a particular network or the respective network. Alright, now this is one thing that DLL does, okay, that is adding source MAC and destination MAC. Now what this whole structure is known as? This whole structure is known as data frames. Alright, so if someone asks you what where data frames are generated, you should know that data frames are generated at data link layer. Alright, the process is known as framing, okay, and sometimes a question can be asked that what do you understand by encapsulation. Okay, through Java or other programming languages we already know, or through the object oriented programming structures we already know, encapsulation is wrapping up of data into single unit, right? So basically it is wrapping up of data from one format to another format according to the layer or according to the functionality of layer. So that is what happens at the data link layer. Data link layer ensures other functionalities as well. One thing that is known as node to node delivery. Okay, so instead of ensuring network to network delivery, which is obviously done by network layer, it takes care of node to node delivery, because there are different nodes that are present between networks. So who's going to ensure that delivery? So data link layer does that. Then it also provides you something that is known as error control. Okay, it provides you something that is known as flow control. Then it provides something that is known as access control as well. So there are multiple functionalities of data link layer. So it is a very important layer. When we are going to discuss this data link layer in detail, you will get to know what is the importance of this layer. All right, so this layer actually covers majority of the aspects that other layers are also covering. But yeah, this layer is different from other layers itself, and other layers have different features as well. They offer different features as well. Now whatever the data that has been generated through data link layer would be passed on to the next layer, that is known as physical layer. Alright, so now what happens in the physical layer? Basically in the physical layer it is nothing but whatever data has been received, now that data would be converted into electrical signal so that it can be sent through the physical medium. This is what physical layer is. Alright, so in physical layer your different types of cables operate. So whatever hardware structure we have, that is nothing but physical layer. It is the moment from where our data starts leaving the device, okay, or whenever we start placing our bit streams onto the channel. Okay, so this is where physical layer comes into picture, and physical layer takes care of all those things. So all the cables that we are yet to study, or whether I'll be taking lecture on those minor topics, that would be a different thing. But yeah, all those cables operate at this layer, whether it is shielded twisted pair or unshielded twisted pair. So it is STP or UTP. Then we have something that is known as fiber optic. Then we have something that is known as coaxial cable. So all these cables we have seen in real life as well. We have used these cables. Alright, so all these cables are part of nothing but physical layer itself. Alright, so I hope you have enjoyed this video. This is quite basic, and there is a lot more to OSI, since we are also supposed to talk about the protocols that are operating at different layers, what devices operate at different layers. But this session is extending to a whole long unit, so I would be covering that part in the next tutorial most probably. So I hope you have understood this thing, and if you have any doubt, just paste your doubts in the doubt class, or you guys can directly ping me on my contact as well. Alright, so thank you so much guys, have a nice day, bye bye, take care.